Hi everyone, welcome back to Everything Mathematics. In this lesson, we are going to derive the identities for the cosine of the sum and difference of two angles. We're going to go behind the scenes of these identities and we'll see how they come alive. Before we do that, we're going to make some assumptions when it comes to background knowledge. We will assume that you already know about the cofunction identities for cosine theta, sine theta, and that you already know the identity for the sine of A minus B. So for example, the cofunction identities. Cosine of theta is equal to the sine of pi over 2 minus theta, and the sine of theta is equal to the cosine of pi over 2 minus theta. Please know that even though I'm using radians here for pi over 2, the same thing is true if we use degrees. So imagine 90 degrees minus theta, same conclusion. Now for the sine of A minus B, this is equal to the sine of A times cosine of B minus sine of B times cosine of A. So these are three concepts that we need to assume in order to derive the other two identities for cosine. Now we're going to go ahead and derive the identity for the cosine of A plus B. And we're going to start with the cofunction identity. The one that says that the cosine of theta, some angle theta, is equal to the sine of pi over 2 minus theta. Again, notice how theta over here matches perfectly over here. So we're going to do that. But the trick will be that for now, we will imagine that all of this is theta. All of A plus B is theta. So then we're going to be able to rewrite this expression as now applying the cofunction identity. We are going to have that this is equal to the sine of pi over 2 minus theta. But remember, all of this over here is theta. This over here is theta. So then we're going to have pi over 2 minus A plus B. Just like that. So then again, we transition from cosine to sine by using the cofunction identity. Now we're going to do a little bit of rearrangement. We're going to rearrange some of these terms inside. In other words, I want to have pi over 2 and A together. So we're just regrouping. We're going to group pi over 2 and A, and B is going to now be alone. You'll see exactly what I have in mind. This is equal to sine, and this is the regrouping now. Pi over 2 minus A. And why minus? Because I do have to distribute the negative to free it from the inner from the inner brackets. So pi over 2 minus A together here minus B. Okay, again, pi over 2 and then minus A because I am distributing the negative here. So that becomes minus, and then another minus over here, minus B. And now, practically, I want you to think of this entire difference as another angle. And now we're going to go ahead and apply the identity for the sine of the difference of two angles. You remember that sine of A minus B is equal to the sine of A times the cosine of B minus the sine of B times the cosine of A. So I'm going to be applying that entire identity. But now what is important is for you to think of this entire difference as a single angle. That's one angle, and then B is the other angle. So then we are going to have sine of pi over 2 minus A. This is this very first factor right here, times the cosine of B minus, now we're going to have sine of B. We are interchanging the angles, and then times cosine of pi over 2 minus A. And now what I want you to notice is the following. Right here, cofunction identities. So now I can go backwards within the identity. Now I know that the sine of pi over 2 minus A is equal to the cosine of A. So then I can replace that with cosine of A. This is this factor. Now this one remains as is. So that will be cosine of B minus this one remains as is. We don't do anything to that one. And this one, again, we can use the cofunction identity. Cosine of pi over 2 minus A is equal to sine of A. And there is the identity. So as conclusion, the cosine of A plus B is equal to cosine of A times cosine of B minus sine of B times sine of A. And this is the identity for the cosine of the sum of two angles. It's actually not that difficult to remember it. What you need to remember is that for cosine, you begin with cosine, cosine. Cosine of A, cosine of B. And then if we have a plus, then here in the middle is always the opposite sign. So it's a minus. And then at the end, you have sine, sine. And then the same angles, sine B, sine A. Or you can have first sine A, sine B. That's irrelevant, right? Which factor goes first is irrelevant. Multiplication is commutative. Now that we have the identity for the cosine of A plus B, we can easily now derive the identity for the cosine of A minus B. Again, we are going to re-express A minus B as a sum, just like we did in a previous video that I will also link in the description below. So cosine of A minus B can be rewritten as the cosine of A plus negative B. And now look at this. Now I have plus. I have the cosine of the sum of two angles. One angle is angle A, but the other angle will now be negative B. But I'm adding them, A plus negative B. So in this case, I can use the identity that we just derived for the cosine of the sum of two angles. So this will be equal to the cosine of A times cosine of negative B. Then, because there is a plus, we're going to have minus sine of A times sine of minus B. And here, something that we need to also remember, and that I will assume that you already know, is the concept of sine being an odd function and cosine being even. I have another video in the channel that goes in depth when it comes to this concept. I'm going to link it below in the description. So what does it mean for even again? If sine is even, that really means that the sine of a negative angle, I'm going to use theta, so the sine of negative theta is equal to minus sine theta. And then cosine is odd. That means that the cosine of negative theta is equal to the cosine of theta. So this is something that in this video I will assume that you already know. So look at this. We're going to use the fact that cosine is even here. This is just equal to cosine of b. And here, the fact that sine is odd, so then that means that this will be equal to negative sine of b. And what is really nice, notice over here, this minus that was already there, with this new minus over here, they will interact together and they're going to give us a plus. So what we're going to have now is the following. We're going to have cosine of A times cosine of B. And now a negative times a negative will give you a positive. And this will be sine A times the sine of B. So then in conclusion, here is the new identity for the cosine of A minus B. So let's look at this again, very similar to the previous one. Cosine of A minus B is equal to cosine of A times cosine of B. But now, since we had a minus, now here we have a plus. Sine A, sine B. So cosine, cosine plus sine, sine. That's how the identity goes. All right, everybody. I hope that you found this helpful. And remember that you're going to pretty much find these identities easy to work with, because after you do many exercises, after applying them over and over again, they will start becoming part of you. You will be able to feel comfortable with the identities, and you will be able to apply them to a wide range of problems. Until next time, bye.